All right, so number 6, we also want to find all the zeros. Being that this is a smaller problem, this is going to be a lot better to do by hand compared to the previous problem, because there are quite a bit of steps and quite a bit of information that you have to remember to be able to do all this and put together. So I'm going to do this one completely by hand. Number 6, we have f of x equals x to the third minus 9x squared plus 16x plus 26. All right. So first I'm going to find the possible rational zeros. You take your last term and your leading, so your constant term and your leading coefficient, which is understood to be a 1. I'm going to divide those. So 26 over 1. We're going to list the factors of 26, so that it's 1 and 26, so 1 times 26. And it's even, so you can do 2 and then 13. And I think that's going to be it. We have no other factors. 1, 2, 13, and 26. The only factor of 1 is 1. And then your completed list would be each number on the top divided by each number on the bottom, positive and or negative. So plus or minus 1 would be in the list. Plus or minus 2 would be in the list. Plus or minus 13. And then plus or minus 26. So this is step 1. Find the numbers that are possible. So these 8 numbers, 2, 4, 6, 8, might work if any of our zeros out of the 3 that we would have are rational, which means they can be put in fraction form. It would be one of these. All right. Now, instead of having to try all 8 numbers, we can kind of limit what we do with some more properties. So we're going to count the number of sign changes. So I'm going to put positive and negative. Okay, so we're counting the number of sign changes. So in the original problem, so I have x cubed minus 9x squared plus 16x plus 26. So I'm counting how many times this polynomial changes sign. So it's positive, changes to negative. So that's 1. And then from negative, it changes back positive. So that's 2. And then positive, it stays positive. So there are 2 sign changes. So either 2 or you subtract 2 and you keep doing that till you get to 0. Either 2 or 0. So either 2 of these numbers will work from the positive side. So 1, 2, 3, and 26. 2 of those. Or none of them will work, and it could come out that they were imaginary numbers. All right. And then we're going to count the number of negative sign changes. So to figure the negative out, from your original problem, all of the odd powers are going to change from the original sign. Even powers will stay the same. So this was positive, it will now become a negative x to the third. Negative will be the same here. And then odd will become opposite sign, so it's going to be a minus 16x, and then that will stay the same because it doesn't even have a x with it. So this starts out negative, it stays negative, it changes to positive. So there's 1 sign change. So as far as negative zeros, there's only 1, and I can't subtract 2 from 1. It will give me a negative 1. That wouldn't make sense. So there's going to be 1 negative 0 and 2 positive zeros. All right. Now I want to do a little bit more work. I want to restrict myself and see upper bound and lower bound, so I don't have to try all of these numbers. So upper bound has to be a positive number that gives me positives along the bottom row. So let me just try 3. If 3 doesn't work, then it means maybe 13 could be a 0. So I'm going to try 3. And you can really start at 1 and go up, but I'm going to try 3 and then I can work these other guys in. So if I try 3, I'm going to list the coefficients of my original polynomial. We got 3, 2, 1, 0, so we have all our terms. So that would be 1, negative 9, 16, and 26. So what we're looking for is positives all along the bottom row. So 3 times 1 is 3, and then combine, and I get a negative 6. So right here, 3 cannot be a possible upper bound. I would have to keep going until I at least did 9, because if I did any other number between 3, when I multiply by 1, it has to be 9 or greater. So let's do this again, and let's go ahead and use the number 9. So 1, negative 9, 16, and 26. 9 times 1 is 9. Combine, we get 0. 9 times 0 is 0, sorry. And then combine, we get 16. And then 9 times 16, 90 and 54, 144. Combine, and we get 170. So all positive, so none of these are negative, so 9 would be an upper bound. What that means is that out of the positive zeros, if they are rational, I don't have to pick anything bigger than 9. So upper bound, upper bound is 9. So that means I would only have to try 2 or 1. I wouldn't even have to try 13 or 26. Now let's try lower bound, because we only get one lower bound number. So I'm going to start out with negative 2, and then I'm going to either go bigger from there or smaller with negative 1. So with lower bound, we want, and this is just kind of hopefully saving you some work. If you had a really big list, you wouldn't have to try so many numbers. This list isn't so big up here, so we could have probably just guessed and checked and found a few of them, because once you find one, you have a quadratic and you can factor and solve the other ones. But anyway, this is a process if you had a really, really big problem. So lower bound, I'm going to pick a negative number. It has to be a negative number. And you want your bottom row to alternate from positive, negative, positive, negative. So my leading coefficients are 1, negative 9, 16, and 26. Bring my first term straight down. Negative 2 times 1, negative 2. Combine, and we get negative 11. Negative 2 times negative 11 is a positive 22. Combine, and we get 38. All right, and then negative 2 times 38 will give us a negative 76. And combine, and we get negative 50. Okay, so positive, negative, positive, negative. So that means that negative 2 counts as a lower bound. But is that the greatest lower bound? That will be the proper term. We need to double check by doing negative 1. That's the only other number before it. So I'm going to go negative 1 and see. And this actually might give me a 0, and then I can start solving the problem from here. So let's try negative 1. So we got 1, negative 9, 16, and 26. Because we do have one negative 0, only one number smaller than it. So bring down the 1. Negative 1 times 1, negative 1, combine, and we get negative 10. All right, negative 1 times negative 10 will give us a positive 10. Combine, and we get 26. Negative 1 times 26 will give us a negative 26. Combine, and we get 0. So look, we did get a 0 for negative 1. So that's one of my zeros. It's the only one that we would get from doing our rule of signs. So we got one negative 0. That was negative 1. And then from there, so my lower bound is actually not negative 2. It is negative 1. Because positive, and 0 can count as negative. But it also ends up giving me my 0. So my lower bound would be -1, and it actually is one of my zeros. And then from here, I can either try to factor this or do quadratic formula. So let me go to another page. This polynomial is x squared, because we started out with x cubed and we dropped by 1. So x squared minus 10x plus 26. So you just follow the signs and just count down, squared, or whatever your highest degree is, 2, 1, 0. And so I don't think this will factor. So we're going to do quadratic formula with this. So now I have x squared minus 10x plus 26. All right, so we're going to do negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And remember, this number is a, this middle number is b, and then this constant is c. So when I plug in a negative to a negative, it becomes positive 10 plus or minus the square root. And if I do 10 squared, I'm going to go ahead and do that. It's going to be 100 minus 4 times a, which is 1, times c, which is 26, and then all over 2a, 2 times 1, which is 2. I'm going to keep working down. So I have 10 plus or minus square root of 100 minus 104. You multiply all this out, all over 2. And then we get 10 plus or minus the square root of -4 divided by 2. All right. And then when we evaluate this, we get 10 plus or minus. This will be 2i, because the square root of 4 is 2, but it's going to be imaginary, so 2i divided by 2. And then both these numbers are divisible by 2, so that will give me 10 divided by 2 is 5, plus or minus, and then 2 divided by 2 is 1, so we're just left with 5i. So my other two zeros are 5 plus I and 5 minus I. And then also -1, that's the one we found by doing synthetic division. So both of these will give you, I guess 5 is bigger than the square root of -1. Well, it is. And so that's your 2 positive zeros, and then that's your 1 negative 0. So if you graph this, if you were to graph this, what you would see is that it was odd and positive. So this graph should be coming up from the bottom, crossing at -1, and probably like turn around in space and then goes back up. So it doesn't actually cross the line again, since we got those two imaginary terms. So -1, 5 plus I, 5 plus I, and then 5 minus I.